Hey, this is Jonathan from Catapult Case. Thank you for making it through the previous videos. This is the exciting one. We're going to go ahead and make a junction. Just to give you a quick recap of what we've done so far, because it matters, you need to have collectors, which are going to poll the data sources. In this example, we'll probably use hardware info and the rate tester. I said it was fun. I'm going to show you that it's fun. We also have a device added. Now the device this time is an Adafruit matrix. It is attached to a 64 by 32 pixel matrix display. That's why it's called the matrix display. So yeah, I'll use some video magic and insert some images of that ESP device. It's awesome. Let's hop to it, right? So we're going to go to the Junctions tab. I'm going to create a new junction. Now, there are lots of different transmission protocols we can choose from. The most straightforward, you would think the most straightforward would be COM, but as I mentioned in the previous video, COM can be a little finicky. I don't like the current implementation. We're not going to do that right now. HTTP is, if you want it super simple, that's a good way to go. You're just going to enter the, it's going to use HTTP requests, so straightforward. The only issue with HTTP is that if you're making a lot of HTTP requests with a lot of different devices on your network, that can be quite a lot of traffic. Which you might not want. MQTT is great if you have an MQTT broker running on your network. That can alleviate some of those HTTP calls and traffic. The first payload, the config payload, can be sent through HTTP. Of course, the compromise with MQTT is that the payloads need to be much smaller to fit inside that envelope. It's something like 250 bytes or so. A virtual junction is what you can use if you just want to stream it to JunctionRelay itself. We'll do a video on that later on. Maybe we'll squeeze it in here, depending on the time. And then we have some gateway junctions down the bottom. That's for another video as well. We're going to use a WebSocket junction for this demonstration. And I'm going to go ahead and call it WebSocket Junction Matrix. And if I want it displayed on my dashboard, I can leave that checked. If I want this to automatically start every time JunctionRelay begins, we can check this toggle. And this all targets all data. I'll explain that a little later. So I'm going to add and configure. And as I've mentioned every video, this is early access. The UI here is very likely to change. But as of the time of publish, this is version 0.855. Early access. So some junction settings, basic info at the top. We're going to stay in WebSocket junction, retry counts, retry interval. That's not actually implemented yet, but that will be soon. And then if this was a gateway, this would matter, and we need to hide this card when it's not. Likewise, MQTT, you should not see that yet. Nothing to change here for this demo. I'm actually just going to dismiss that card. This is the important piece, right? So we set up collectors and we set up devices. A junction brings them together. Right now you can add any of the following as a source or a target. I haven't decided right now if we're going to restrict, hey, only the collectors can be sources, only the devices can be targets. Not sure. I'm going to leave that open for the time being. What I will do is I'll select hardware info as a source. Give that a second. Let's also add the rate tester as a source. And as I mentioned, we're going to use the matrix desktop device. The IP address looks correct. Let's go ahead and send that across. Okay, source and targets. JunctionRelay, it's one of the many nice things it does is it collates all of the sensors that need to be polled in each cycle from all of your junctions, and it will make one poll to the data source rather than them all doing individual fetches. So it will always do that at the rate that is fastest to make sure that every junction has every junction is going to have the most up-to-date data at the poll rate that it wants, but to do that it needs to poll at the fastest rate. So these have defaulted themselves to 100 milliseconds, which is that 1 second? And the send rate is how fast we're going to communicate the data out to the matrix device. I'm going to change that to be 1000 milliseconds as well. Rendering mode configuration. This is very important for junctions. There are 3 primary rendering modes. Standard data payloads is what we're going to use here for this one. And basically this is applicable for any device that is not with a traditional screen. And this is as I mentioned, a matrix panel. So we're going to be sending raw JSON as our data. And that's what we'll do for this demonstration. So in the last video, we talked about the screens the device needs to have. We added the onboard screen just as a demonstration. This one actually comes preloaded in the firmware within a matrix panel. So we are going to select a template that is appropriate for the matrix display. And what we can do now, this is all auto-saving as we go. So let's go up to the Payloads tab, which we took a quick look at in the navigation video, and just take a quick peek at the template that's the one we selected. So template matrix display, if I click onto that, it is pre-configured to work with the demo firmware that is loaded onto this ESP32. And it's expecting a config payload that looks like this, and sensor payloads that look like this. Now again, early access, probably going to remove the position coordinates from the sensor payload and keep it more generic for the standard payloads. There will be other ways to send this additional information, but this is pretty old part of the build. We've been working on this for almost 2 years now, so this is something that's due a bit of a makeover, but I wanted to go ahead and get this out, early access, get some feedback. This is a template, so you can't edit anything here, but you can clone it if you do want to make changes. You would go to Payload, Matrix, clone it, and then you can actually edit this one however you like, and that's true of all the templates. Let's go back to our junction. Matrix. Scroll back down, we have the right template selected. Target poll rate, that is really there with e-ink displays in mind. It's not implemented in any of the demo firmware yet, but that would be, hey, you tell me when you want this information. For the time being, this is going to push it out at the frequency we specified up here. Let's go past this. This is where we get to do the fun thing, and that is selecting the sensors that we want to use. And you can search, filter by unit. There's a few different ways to view the sensors here. Some of these are better for mobile. I'm going to keep things simple. Let's do CPU. I don't want... That's temperature. So because I'm using hardware info, it's coming through with a lot of decimal places on some of these, which makes me laugh. We'll be able to override that anyway. CPU package temperature is not, that's 0 decimals. Let's take that. So we need to select the sensor on the far left, and then we also need to select the target over here, because I'll show you if we have multiple devices added in this junction, you can select it once. Where'd it go? Show selected only. You would select the sensor and then select all the targets that this sensor needs to be sent to. You might decide to do one device per junction, multiple devices per junction. It's flexible. Do it the way you want to. I'm just going to do the Matrix desktop right now. And if you remember what I said before, it must have a screen. Right now, this will not know where it needs to go when it gets to the Matrix. So I need to select the Matrix screen that we added earlier and press save. Scroll back down, get rid of selected only. We've added one. Let's see. Hardware info is going to know about my GPU as well. Let's filter for percent. We'll do usage instead of temperature. Sensor tag is a little crazy in hardware info. I need to see if I can update that to be more meaningful, but it needs to be the sensor name, and it's how you kind of define the label as it's going to be sent in the payload. So let's go ahead and say yes. Let's send D3D usage, and we'll call this GPU usage. You know what? This is a matrix display, very tiny, 64 by 32. So we need to be very mindful about the labels. They need to be short. Oh, they won't fit, as you'll see. Let's add display to that device. Scroll back down. Take another look. I didn't do the sensor tag for the CPU package, so that's going to be CPU. We do want to, at this point, make sure that our decimal places is not going to be 16 because that's going to look crazy on the display. We can edit that sensor here, change decimal places, save. And in this early access, there is a bug where if I don't refresh, it won't. Remember that we did that, so you won't have to do that, hopefully, by the time you get hands-on with this. Let's go ahead and get rid of show selected only. I'm going to add one more sensor, and I want it to be the rate tester. I told you that this one's fun. I'm going to show you how fun it can be. We select this, just call it RTE. I think 3 characters is about the max we can get away with on this matrix panel. Okay, scroll down. Oops, too far. Show selected. This junction, to me, to my eye, looks pretty much ready to go. We've got the 3 sensors selected. This screen will handle 4, but I'm just going to do 3 for now. We've got the device selected as a target, and we have its screen selected as the screen on the device. Because some devices might have more, right? If I plugged in a quad alphanumeric kind of thing over the I2C bus, quick connect, that could appear here as well, and I might want to send different sensors to that. We'll do that in a future video as well. I think we're good to go. What I'm going to do now is start my camera. Okay, I'm going to reboot the matrix display now, and then give it a few seconds to boot up on the demo firmware. It's running. It has a startup screen confirming you want to use Wi-Fi, or do you want to use ESP now, COM, etc. So we're on the home screen now. There is a bug right now where it's saying no network. I think it probably is connected. But here's the moment of truth. We're going to go ahead and press start on our junction. Perfect. All right, that's updating at the expected rate as well. I am wondering why it has an abbreviation on the CPU. I suspect that's because this is actually a bug. I wondered why it was a whole number here. Let's go ahead and put in an override of decimal places as 0. And we'll see if stopping and starting it fixes that. No, it does not. What is the unit here? Ah, it's because it's trying to draw that as well. So let's go ahead and change that sensor. No, we'll leave it. Let's just make that label smaller. There we go. So that's why I was so careful with the sensor tag label, because you can't fit a lot of characters on this display. At least not with the font I'm using on the demo firmware. And as you can see, it does not draw the little degree symbol very well. It doesn't matter. For the purpose of the demo, this is doing what it was meant to do. It is now sending data to that matrix display. The fun thing to show you, Home Assistant, Hardware Info, all these different services, they have a default rate that they are polling data. And actually, if you go into Hardware Info, we can see, where did I see it? Somewhere in here it does talk about how fast it's actually making these polls. You know what? I bet it's in here. Yeah. Global polling period. So this one's actually pretty slow, 2,000 milliseconds. Home Assistant, I believe, does 1,000 milliseconds as default. This is where the rate tester can come in use, because we're in full control of this. And as I mentioned in the collector video, we can do what we want with this one. If we change the rate tester to test at 100 milliseconds, we obviously have to send data to the matrix at the same speed. When I press start now, excellent. That sensor is now going much quicker. It actually looks a little jittery on that display. I don't think it's actually unstable. If we go to the dashboard, we get these visualizations of the polling taking place, and that's looking pretty smooth. Same with hardware info. And if we scroll down, so yeah, I mean, all sorts of things. This is, at the end of the day, an internet protocol we're using, so it's susceptible to latency. It's actually running on Wi-Fi, So that can explain some of the jitter. There is some code in the demo firmware trying to compensate. What we can do for now though is just slow that rate down slightly, do 200, and that should give a bit of a, that's much better. So that looks much more smooth and stable as well. So the performance that you get is going to vary based on your hardware, your networking, and so on. Of course, I've been slagging off COM connection for a while in these videos, but it gives you that zero latency perfect result. Then again, so does an hardwired Ethernet based ESP32, or if this was a Pi, you can get perfect performance there as well. So you know what? I stand on that hill. Still not a fan of COM, even in this video. Okay, I'm going to keep this video short and sweet. That junction is working, so on to the next video. Cheers.